Good day, grade 8 learners. Welcome to the Natural Sciences lesson. My name is Terigle Teve, and this program is proudly brought to you by the Gauteng Department of Education. Welcome to our final lesson of the term. We're going to be looking at energy transfer in electrical systems, and our subtopic is static electricity. You still remember this topic, don't you? Let's set goals. By the end of this lesson, we're going to be able to define static electricity and explain how materials become electrical charged. We're also going to look at how to describe like charges and opposite charges. Remember, like charges repel and opposite charges attract. Right. And then we're going to state why electrostatic discharge occurs and describe what happens during electrostatic discharge. And we're also going to explain the dangers of electrostatic discharge. We get all this from the CAPS document, page 47 to 48. Let's look at the pre-knowledge. This is what we have learned in the previous grades. Remember when you were in grade 6, you did energy and change. This is what we are doing now. We're just building on to what you already know. And then by the end of this lesson, we are going to entertain your WhatsApp questions. And our number is 064 748 8913. Our number again, 064 748 8913. If there's something that you don't understand, make sure you ask by just texting us on our WhatsApp number. Don't call, don't make voice notes. All right, we've got an amazing team which is going to look into your questions and answer you. Let's look at the baseline activity. We are going to remind ourselves of what we have already learned. We're going to study the structure below and answer the questions. This is the structure of what? Of an atom. All right, this is a carbon atom. Why am I saying it's a carbon atom? Because we can see how many electrons here? 1, 2, 3, 4, 5, 6. All right, if we're looking at the structure of an atom, in the center we've got a nucleus. The nucleus is the center of an atom. And what is in the nucleus? We've got the positive protons, positively charged protons, and we also have what? Neutral neutrons, which don't have a charge. And they're held together by a what? By a strong force. And then what is orbiting around the nucleus are the electrons. And these electrons are in a what? In a first shell. In the first shell, we've got 2 electrons. The first shell can only hold 2 electrons. The first shell is the first energy level. All right. And then the second shell here, it can hold up to 8 electrons. But in this case, this is an example of carbon, which has got the atomic number 6. And then how many electrons are in the outer shell? We've got 1, 2, 3, 4. All right, this is the second energy level. Let's look at the questions. You are going to answer the questions here. Question number 1 says, if this atom is electrically neutral, how many protons does it have? Question number 2, how many electrons are in the outermost energy level? I'll give you 2 minutes to answer the baseline activity. Please answer on your own. Start writing. Let's look at the questions again, grade 8. Question number 1 says, if this atom is electrically neutral, how many protons does it have? Question number 2, how many electrons are in the outermost energy level? Let's check the solutions. For question number 1, the solution is it will have the same number as the electrons. Then 2, solution number 2, there are 4 electrons in the outer shell. All right, and then let's look at the terms. Remember, we've got terms that we need to define. Even in our examinations, you're going to come across terms that you're supposed to define. From now up to grade 12, you'll be defining terms, and each term contributes about, it carries 2 marks per term. All right, so it is very important to take advantage of these marks. Our first term that we're going to define is friction. What are we talking about when we're talking about friction? Friction is a resistance against the movement of an object as a result of its contact with another object. All right, that is friction. For example, if you take a glass rod and a silk cloth and then you rub against each other, that is friction. And then what is going to happen? The electrons in the glass rod will be transferred to the cloth. All right. The same number of electrons that are going to be transferred from the glass rod to the silk cloth are the same number of electrons that the silk cloth is going to what? Is going to receive. Why? Because we cannot destroy or make them. Let's define the second term. Electric charge. What is electric charge, grade 8? If we're looking at an electric charge, we're looking at the positive and negative property of a what? Of a particle. That's what we'll be talking about when we're talking about an electric charge. Remember, when we're talking about the positive, these are the protons, and the negative, these are the electrons. All right. And then static electricity. Let's define static electricity. It is an electrical charge caused by the buildup of electrical charges on the surface of an isolator of electricity. That is an insulator of electricity. And then let's move on, grade 8. Let's define more terms. Let's define attract. What do you think the word attract means? If we're looking at attract, it means to make something move towards one another. All right, that is attracting. For example, unlike terms, unlike charges, attract because they are unlike. They come together. All right. For example, if you take a positive and a negative and bring them together, what's going to happen? These are unlike charges. They are going to attract. Do you get that, right? 8. That's good. Let's move on. And then we've got repel. If we are saying things or objects are repelling, it means that they are pushing each other away. Why? Because they are like charges. And if I say like charges, what do I mean? If it is a negative charge and a negative charge and you bring them together, they are going to push each other away. They are going to repel each other. And even if you take a negative and a negative, they are like charges. They are going to repel each other. They are going to push each other away. Do you get that, grade 8? That's good. Let's move on. And then we've got electric discharge. What do we mean when we say electric discharge? This is a release of what? Electric charge through a solid, liquid, or even a gas. And then static electricity. Atoms are made up of positively charged protons and neutral neutrons that are tightly packed in the nucleus. The negatively charged electrons are moving freely around the nucleus. All right. Now here we're talking about a structure of an atom. For example, this is the structure of an atom. This picture is the structure of an atom. In the center here, we've got the nucleus. What is in the nucleus? We've got positively charged what? Protons in the nucleus and neutral neutrons. If we say neutral neutrons, it means they don't have a charge. They are neutral. Right. They are held down by a strong force. Do you get that? And then what is orbiting around? Electrons are orbiting around. And if we're talking about orbiting, do you understand grade 8 what we're talking about? Orbiting, this is revolving or rotating, moving around the nucleus. That is orbiting. Okay. And then a neutral atom has an equal number of negatively and positively charged particles. This one is a structure of a carbon atom. Why am I saying it is the structure of a carbon atom? It is because of the atomic number. The atomic number is what? Is 6. Why are we saying the atomic number is 6? Let's count the electrons here. We've got 1, 2, 3, 4, 5, 6. And do you see the structure of an atom? We said in the center we've got the nucleus, which comprises of protons and neutrons, and they're held down by a strong force. And then we've got the first energy level, that is the first shell from the nucleus. The first energy level can only hold up to 2 electrons, and we've got the second energy level, which can hold up to 8 electrons. But in this case, on the outer shell, that is the second energy level, we've got 1, 2, 3, 4. All right, and we add that with the electrons in the first energy level, which is 2, then it will become 6, then it is the carbon atom. But if we take, for example, sodium is Na11. The atomic number is 11. It is going to appear like this. We've got the nucleus here, which comprises of the positively charged protons and the neutral neutrons. And then the first energy level, this is our first shell. Remember, the first energy level said it can hold up to 2 electrons only. And then the second shell, that is the second energy level, it can hold up to 8 electrons. Let's put the 8 and observe. 4, 5, 6, 7, 8. 8 plus 2 is equal to 10. But here we're looking at the structure of sodium. Therefore, let's add the third energy level. That is our third shell. And then 11 subtract 10 is 1. Therefore, we're going to put 1 electron here. Then it will become 11. All right. Hope you understand. Let's move on. Static electricity. Friction is a force caused by rubbing things together. Okay. For example, if you take a glass rod and a cloth, then you rub these together. All right. This is friction. And what's going to happen? The electrons from the glass rod are going to be transferred onto the silk cloth. All right, leaving the glass rod positively charged, and the cloth will be negatively charged because it has received what? It has received electrons. And then if you bring these two together, remember now they've got different charges. The glass rod will remain positively charged and the silk cloth will be negatively charged. And then if you bring them together, these are unlike charges. They are going to attract. They are going to come closer to each other. All right. And then friction between objects causes electrons to move from one object to another. The object that gains electrons becomes negatively charged. Okay, it becomes negatively charged because it has more electrons than protons. Do you get that? Because it has gained electrons. And the glass rod has lost some electrons. Do you get that? And then the object that loses electrons becomes positively charged. Why? Because it has lost electrons. Okay. And remember, the same number of electrons that have been transferred from a glass rod to a silk cloth are the same number of electrons that the silk cloth is going to receive. It doesn't change. All right, that is very important. Make sure you note that, grade 8. And then charging by friction. For example, this is a what? A glass rod. Okay? And then this is a what? A silk cloth. You can rub these two together. Okay? And then what's going to happen? The electrons are going to be transferred onto the cloth. And then the glass rod will remain positively charged, as you see on this picture here. Okay? And then what will happen to the cloth? Remember, it has gained some electrons. Therefore, it will be negatively charged. Then, if you bring them together, remember now they are unlike charges. They are going to come together. They are going to cling together. All right? Because they are attracting. And then, electrons are never created or destroyed. They can only be transferred from one place to another. That's why we are saying the same number of electrons that the glass rod loses is the same number of electrons that the silk cloth is going to receive. Easy, isn't it? Good. Let's move on. The number of electrons that one object loses is the same number of electrons the other object gains. Only insulators can become electrically charged through what? Through friction. Remember, insulators are bad conductors of electricity. They are not conductors of electricity. Remember that. Good. That's why we are saying only insulators can become electrically charged through what? Through friction. Okay. And then insulators do not conduct electricity. They don't conduct electricity at all. Right. But they can hold a substantial charge. The imbalance that occurs between the negative and the positive charge in an atom is called what? It is called static electricity. And then we've got an activity that I want you to start working on. We are going to look at the questions together, but you're going to answer on your own. Then we're going to revise together. Question number 1 says, how do electrons move from one object to another? How do electrons move from one object to another? And then question number 2, what is static electricity? What is static electricity? Question number 3, which charges move when objects are rubbed against each other? When objects are rubbed against each other, which charges move or which charges are transferred? And then question number 4 says, what is the electric charge of an object that loses electrons? What is the electric charge of an object that loses electrons? I'll give you 5 minutes to answer those questions. Start answering the questions, grade 8. You are done, isn't it? For example, let's look at question number 1. How do electrons move from one object to another? How do they move? If we're talking about electrons, the movement of electrons, remember we are doing static electricity, we're doing energy transfer. Therefore, if you take a glass rod and a silk cloth and then you rub against each other, that is friction. Okay. And then what's going to happen? The glass rod is going to lose electrons. They will be transferred onto the silk cloth, and the silk cloth is going to receive the number of electrons that the glass rod has lost, therefore leaving the glass rod positively charged, and the silk cloth becomes negatively charged. Why? Because it has gained electrons. Do you get that? And then let's look at question number 2. What is static electricity? If we're looking at static electricity, we've got the imbalance of what? Of charges. We've got different charges. And then remember, static electricity, this is the accumulation of what? Of charges on an insulator. All right. The accumulation of charges on an insulator. And remember, an insulator is a what? Is a bad conductor of electricity. Which charges move when objects are rubbed against each other? If objects are rubbed against each other, which charges move? Remember, we've said electrons will move. All right. They will move from one object to another. The same number of electrons that are lost by one object will be gained by another. For example, in our case, if you take a glass rod and a silk cloth and rub them together, what's going to happen? The glass rod is going to lose electrons, and then the silk cloth is going to gain electrons. Does it make sense? Yes, it does. Good. And then, what is the electric charge of an object that loses electrons? Remember, if a glass rod is going to lose electrons and the silk cloth is going to gain electrons, the silk cloth is going to have more electrons. Therefore, it will be negatively charged. And then the glass rod is losing electrons when we are rubbing against what? Against a silk cloth. Therefore, it will be positively charged because it has lost what? Electrons. Is that clear? Good. Let's check our solutions. For question number 1, we said the answer is what? It is friction. For question number 2, it is an imbalance of charges. For question number 3, it is electrons. Then question number 4, it is protons, okay, which are positively charged. Let's look at the effect of charged objects on each other. An object becomes electrically charged when it is rubbed against another. Through what? Through friction. If you rub an object against another through friction, these are what? It becomes electrically charged. This charge can either be what? Positive or negative. All right, if we say positive, it will be the protons, and then negative, these are electrons. A charged object influences other charged or even neutral objects. Okay. Objects with different electric charges attract each other. They move closer to each other. For example, let's say you are moving on a carpeted floor. You are going to gain electrons. And then if you touch your friend is going to experience a shock. Why? Because you've got more electrons. Even when touching a doorknob, you can walk on a carpeted floor, and if you touch a doorknob, you will feel the shock. Why? It is because you've got more electrons, and then there is an imbalance of charges between you and the doorknob. Do you understand that? Let's move on. The effect of charged objects on each other. What is the effect of charged objects on each other? Let's look at static electricity. Objects with the same charge they repel each other. For example, if you take a balloon and another balloon, two balloons, and then the side which is positively charged and the other one which is positively charged, these are like charges. And if you try to bring them together, they are going to push each other away. They are going to repel each other. Why? Because like charges repel each other. They push each other away. But if you take a balloon, the side that is negatively charged, and you put it on a wall which has got the what? The positive charges, they're going to attract. Okay. That's why at times if you rub a balloon against yourself and push it to the wall, it sticks for a while. Why? It is because unlike charges attract. Do you get that? Unlike charges attract. But like charges repel. They push each other away. But if they're attracting, it means we've got unlike charges. For example, this is a what? A positive charge. And this one, a negative charge. What's happening here? They are attracting, they are coming close to each other. All right, there's an attraction. But if it is the same charge, like charges, like this one here and this one here, these are like charges. Positive and a positive, you bring them together, they push each other away. They repel against each other. Even if it was negative and negative. And if you try to bring them together, what's going to happen? These are like charges, all right? They are going to push each other away. And we call that repulsion. They are repelling each other because they are like charges. Do you understand that? Good. Let's move on. The effect of charged objects on each other. Let's look at the effect of charged objects on each other. Objects with the same electrical charge repel each other. If it is negative and negative, these are like charges. They are going to push each other away. We say they repel each other. Even if it is a positive charge and a positive charge, this object is positively charged and this one is positively charged. If you bring them together, what's going to happen? These are like charges. They are going to repel each other. They are going to push each other away. Okay. And then let's look at the what? At the unlike charges. For example, this is positive, this is negative. If you bring these two objects together, what's going to happen? They are going to attract. You see, they're different from these ones. These are like charges. They repel. All right. Repulsion is the tendency of objects with the same electric charge to move away from each other. They move away from each other because they've got the same electric charge. Negative and the negative, they'll push each other away. Positive and the positive, push each other away. Why? Because they are like charges. Electrostatic charges are best obtained in dry weather. There is no disturbance. It's dry weather, then they are best obtained. Not in a place which is wet. Let's move on. Static electricity is the build-up of electric charges on the surface of an object, which is usually a non-conductor of electricity. Right. Static electricity will build up on an insulator. If we're talking about an insulator, this is a non-conductor of electricity. All right. Therefore, there will be a build-up of what? Of electric charges on the surface of that object. Okay. And then the charges remain static on the surface of the object because they are not moving. They will be static because they are not moving. All right. And then when there are too many charges on the surface of an object, the charges will move to a neutral object or positive object. This is called electric discharge. All right. We've got a lot of examples of electric discharge. For example, lightning. It's fatal. Okay. That is an imbalance of what? Of charges. All right, let's further look at electric discharge. Electric discharge is the release of electrons through a solid, liquid, or even gas. Electric discharge is a release of electrons through a solid, liquid, or even gas. Discharging can take place when objects touch each other, but also when one object is brought near another object without touching each other. All right, even without touching each other, there can be a discharge. Even touching each other, there can be a discharge. A discharge of electrons causes the sparks or shock of static electricity, especially when the air is dry. Okay, for example, if you take off your jersey at night when it is dark, what are you going to see and hear? You will see sparks, okay, electric sparks, and then you'll hear the crackling of the jersey. Okay, lightning is an example of a what? Of an electric discharge. It is a good example. Although sparks caused by static electricity are harmless, an electric discharge can also be very dangerous. For example, lightning. Lightning can kill. It's fatal. It can kill. Okay, it is very dangerous. And then let's look what happens in the clouds when we're talking about electric discharge. Let's look at this picture. This is a very good picture. All right. This is positively charged, and here on the atmosphere we are having charges, even if we can't see them. Okay. And then when these charges and these charges, if they are unlike, they're going to attract each other, there is an imbalance between the charges. Therefore, we are going to experience electrostatic discharge. Okay, it's going to be an electric discharge. And then here we've got positive and negative. Then we're going to have what? Lightning. As you see, these are electric discharges. This is lightning. You can see this is positive and negative. There is an imbalance of charges. Then we're going to experience what? Lightning. Even here on the ground and the what? The clouds. This is a small center of positive charge and this one is negative. Then we are going to experience what? Lightning. And remember, it is very dangerous and it is fatal. All right, so we're going to write activity 2 now, grade 8. Let's check our questions. Question number 1 says, how does a charged object affect another charged object? Question number 2, what is an electrostatic discharge? Question number 3, what is the result of a discharge of electrons? I'll give you 3 minutes to answer the questions. And after answering the questions, please just shoot a picture of your work and send us on 064 748 8913. Our number again, 064 748 8913. Let's start answering the questions. Done writing grade 8? That's very good. Let's look at our questions again. Question number 1 says, how does a charged object affect another charged object? Question number 2, what is an electrostatic discharge? Question number 3, what is the result of a discharge of electrons? Were you able to answer the questions? Make sure you send us on our WhatsApp number, which is 064 748 8913. Our number again, 064 748 8913. Let's check our solutions. For question number 1, objects with like charges, they will repel each other if they are like charges. What do we mean if we are saying objects with like charges? Okay. If we've got a positive and a positive, these are like charges, they are the same. All right, what's going to happen? They are going to push each other away, they are going to repel each other. All right, we call that repulsion. And even if it is a negative and a negative, for example, negative and a negative, what's going to happen? These are like charges, they are going to push each other away, they are going to repel each other. We call this what? Repulsion. But if it is a positive and a negative, what's going to happen? They are going to attract. Why? Because they are unlike charges. They are not the same. They are unlike. Therefore, they are going to attract. They are going to move together. They are going to move closer together. These are unlike charges. All right, and then question number 2, the answer is, it is an imbalance of what? Of charges. And then question number 3, the answer is, it can lead to a shock or even fires. All right, if we're talking about a shock, we've talked about touching a doorknob. At times you feel that shock and you wonder why, especially after moving in a carpeted floor. All right, if the room is carpeted and you walk on a carpeted floor, then the electrons from the carpet will be transferred to you. And then when you touch your friend or you touch a doorknob, you will feel the shock when you touch the doorknob. But if you touch or shake your friend is going to feel that shock. All right. And then let's summarize our lesson, grade 8. Friction can cause the build-up of friction can cause the build-up of what? Electric charges on the surface of an object. For example, let's take a silk cloth and a glass rod, and then we rub these two together. What's going to happen? The electrons are going to be transferred from the glass rod onto the silk cloth, and then the silk cloth is going to gain more electrons. Therefore, it will be negatively charged because electrons are negatively charged. And then the glass rod is going to be positively charged. Why? Because it has lost electrons. Do you get that? The friction is causing the build-up of these electric charges on the surface of an object. And then the other example, if you take a plastic comb and you comb your hair, what's going to happen? The electrons are going to be transferred from your comb to your hair. And then your comb is going to be positively charged, and your hair, which has gained electrons, will be negatively charged. And if you bring the comb closer to your hair, what's going to happen? Your hair is going to stand up. Why? It is because these are unlike charges. The hair is negatively charged and your comb is positively charged. All right, these are unlike charges. Therefore, unlike charges attract. They will be attracting. Okay. Even if you take maybe a glass rod and any piece of cloth and rub these together, electrons are going to be transferred from the glass rod to your silk cloth, and then when your silk cloth will be negatively charged and your glass rod will be positively charged. If you bring them together, they will cling to each other. All right. Even if you take a balloon and wrap it against your jersey and then you put it on a wall, it will stick for some time because unlike charges attract, therefore it will stick on a wall, but for a short while. And even if your sock is on the wall and there is wind, and then it will cling onto a wall from your washing line for a short time. Why? Because it has charges that are unlike the charges on a wall. Do you get that? But it will be for a short time. Let's move on. And then electrons can move from one material to another, causing some material to be negatively charged and others to be positively charged. Here we're talking about what? Electrons moving from one material to another. All right. And then remember, it is the electrons only that move, that can only be transferred from one material to another, not protons, but electrons. Do you get that? They can be transferred. And if electrons are transferred from one material to the other, the same number of electrons that are moving from one material to the other are the same number of electrons that the other material is going to receive. Do you get that? Good. And then let's move on. Unlike charges attract and like charges repel. All right. If we're saying they repel, like charges repel, they push each other away. But if they attract, they come closer to each other. Why? Because they are unlike charges. All right. These are unlike charges. We've got a positive and a negative. These are unlike charges. They are going to attract. But if it is like charges, it can be negative and a negative. If you bring the material which is negatively charged and another one which is negatively charged together, what's going to happen? They are going to push each other away. They are going to repel each other. Do you get that? And then if you take a material that is positively charged and another one which is positively charged and bring them together, these are like charges. They are going to push each other away. They are going to repel each other. We call this what? Repulsion. Okay. Let's move on. And then the discharge of electrons can cause shock or even sparks of static electricity. This is the discharge of the discharge of electrons can cause shocks or sparks of static electricity. Okay. For example, when we look at lightning, we've said lightning is fatal. Right? It can kill. That's why in tall buildings, you will find out there is a what? There is a copper rod. If the building is very tall, there will be a copper rod which is going to attract the lightning and take it to the ground. Rather than for the lightning to strike a building, it will be transferred to the ground. Do you get that? Good. Let's check our WhatsApp questions, whether we've got any WhatsApp today. It seems we don't have any WhatsApp questions. Therefore, we are going to continue with our lesson. But if you come across any questions, make sure, feel free to ask. Would love to answer you. We want you to understand this topic. All right. But if you understand, that's fine. That's our aim. We want you to understand. And I'll give you our WhatsApp number again if you feel there's something that you didn't understand. Ask us on 064 748 8913. 064 748 8913. Make sure you text us, don't call, and don't make voice notes. We've got an amazing team behind the scenes who are willing to answer all your questions so that you understand this topic. All right. Remember, it is the last topic of the term. Therefore, we want you to understand. And then we've got a homework activity. I want you to answer these at home, but now you are going to copy them. Let's check the questions together. Question number 1 says, explain the following concepts. A, static electricity. B, electric charge. C, electric shock. D, electric spark. And E, electric discharge. And then question number 2, a sock falls from the washing line and clings to a wall. Explain how this is possible. And B, what makes the sock fall from the wall eventually? Copy these questions. I'll give you 5 minutes to copy your homework activity. Hope you are done copying the question. Question number 1 says, explain the following concepts: A, static electricity; B, electric charge; C, electric shock; D, electric spark; and E, electric discharge. Question number 2. A sock falls from the washing line and clings to a wall. Explain how this is possible. B, what makes the sock fall from the wall eventually? This is our homework, grade 8. So make sure you go home and do this homework, and then you bring the work to class. And then don't forget that when we are talking about these charges, we've got the positive and the negative. If it is positive, a material is positively charged and another one is negatively charged, they are going to attract. Why? Because they are unlike charges. But if they are like charges, that is positively charged and another positive charged material, if you bring them together, they are going to push each other away. It means they repel each other. All right, do you get that? And then if you rub the materials together, for example, if you take a glass rod and a silk cloth and you rub them together, what's going to happen? Electrons are going to be transferred from a glass rod to a silk material, leaving the glass rod positively charged and the material negatively charged. Why? Because it has gained electrons. All right. And then these will be unlike charges because this one is positively charged and this one, which has gained electrons, will be negatively charged. Therefore, they are unlike charges. Therefore, unlike charges do what? They attract. They will move closer to each other. Do you get that? And then, if a material is negatively charged and another is negatively charged, if you bring them together, they're going to repel each other because they are like charges. Same applies to protons, the positive charges. If you bring two materials together that are positively charged, they are going to repel each other. They're going to push each other away. Do you get that? That's good. And then, even if you take a balloon and rub it against your jersey, and then you stick it on a wall, what's going to happen? It's going to stick for some time. All right? Because of the charges. Do you get that? Even if you take a comb, a plastic comb, and then you start combing your hair, what's going to happen? The electrons from the comb are going to be transferred to your hair, okay? Leaving the comb positively charged and making your hair negatively charged. Why? Because it has gained electrons. It has gained the same electrons that the comb lost. Therefore, if you bring the comb closer to your hair is going to stand up. Why? Because we've got two different charges. All right? They are attracting because the comb is positively charged and your hair is negatively charged. Therefore, they will come together. They are attracting. Do you understand this, grade 8? Hope you do. Let's move on. The brief preview of the next lesson. In our next lesson, next year, we are going to look at electric circuits. All right, here is a reminder. Make sure you press the complete and continue button so that we'll see that you have completed the lesson. Hope you have enjoyed the lesson, grade 8. Thank you very much. Make sure you always sanitize your hands, maintain social distance, always wear a mask, and be kind to one another. So long for now.